Okay, I hope everyone's doing fine tonight. Today is November 6th, and I want to do a couple of things before we get on to our new study guide. The new study guide is one-step equations and function tables, but I want to review a couple of things that the students will be seeing again this week, so bear with me just a few minutes and I will move on to the new study guide. First thing I want to talk about on Wednesday, probably on Wednesday, we're going to do a little review practice test to get us ready for our test next week. So I want to go through a few things with you on simplifying, evaluating, and writing expressions. This is what the students will be seeing. All right. If you look at the first set of problems, simplify each expression. I'll give an example. All right, and it always goes back to your order of operations. Everything that we're doing goes back to that. You must do your parentheses first, then if you have any exponents, which we will not in these problems, then multiplication or division from the left to right, and then go back and do any addition or subtraction from left to right, whichever comes first. So I'm just going to do a couple of these just to make sure everyone is still up on this. So let me do number 2. Right, if you look at the problem, 10 minus 8 times 4 divided by 16. If you go in any order you want to, or an order that you think is easier for you, you may not get it right. So what you have to do is follow your rules. My rules say to do any parentheses. I don't have parentheses. Then do any exponents, no exponents. Then I go back and look and see if I have any multiplication or division. Well, I do. I have a multiplication and a division. Which one do I do first? Well, my rules say to do the multiplication or division as it occurs going from left to right. So in this case, I'm going to do my multiplication first. Alright, so let me get rid of this here and I'll get started. I'm going to make it a little bit larger before I get going here. As usual, it takes me a minute to get going on these problems. Okay, that's a little better. A little bit easier to see, a little bit easier to work around. First thing I'm going to do is my multiplication. I tell the students to work right beneath the problem and then just do one thing at a time so they don't get lost. Well, 8 times 4 is 32. I haven't done 10 minus whatever this was. I haven't done this. All right, now, students complain because they said that's too much work, but it really keeps them organized and they know they've done everything. Just bring it straight down. All right, what do I do next? Well, I look at it again. Do I have any multiplications or divisions left? I do, right here. So I'm going to bring this down. That's 2. I still haven't done this. I go back and look at it. I have completed all my multiplication or division. Now I go back and do I have any addition or subtraction? I do. I do this, and I have evaluated my expression, or simplified my expression, excuse me, and I'm done. All right, I want to do one with parentheses. Now the students have done very well on these, by the way, in class, so I don't anticipate this being a problem. Once again, we'll have a practice test this week. Matter of fact, these problems are right from the practice test, and then next week we'll have a test that counts. All right, the first thing I'm going to do on number 4 is to look at it. I see 2 sets of parentheses, so I'm going to do this first. 14 minus 8 is 6. Now, I'm a stickler about what I tell the students. I tell them to do one thing at a time so they won't get lost again. All right, what do I do now? Well, I'm going to do this now. That's going to be 2. I'm going to write down everything that I haven't done. You can see I've done that. This has been replaced with 6. Okay, now it's clearing up nicely. All right, what do I do now? I look at it, I've got an addition and I've got a division. Well, I have to do my division first. Bring it down. I've got a 3. I'll write down what I haven't done. 80 plus 3 is 83. All right, so if the students do it properly, I tell them it looks like an upside down Christmas tree or just a triangle because it gets smaller and smaller as you go down the expression. All right, so we've simplified a couple, and once again you can see these aren't too bad. Now, I do have one little situation to show you why the importance of following your rules is there to help us. All right, in number 5 and number 6, I've got parentheses in number 5. I don't have parentheses in number 6. So I'm going to do my rules. Just show you why it's important to go by your PEMDAS rules. I do my parentheses first. I get 11. 32 minus 11, 21. All right, now, I don't have parentheses in number 6, so I just go straight across. I do 32 minus 18 first, and I think that will be 14. 14 minus 7 is 7. And you can see what happens. We've got exactly the same numbers, but you did this first in this problem, you did this first in this problem, you got totally different answers. So that's why your rules are there, is to help guide you and keep you on track. So I tell them that the rules are their best friends if they use them properly. All right, let's evaluate a couple of expressions real quick. In these particular problems, tell them to evaluate the expression, which means simply to find out what it's worth. All right, and then I give them a value. Like in number 1, I say 56 minus 15 times n, when n is 2. So the first thing they do is wherever they see n, they substitute 2. All right, so I'm going to write this down. All right, now once again, I have to use my PEMDAS rules. I can't just say 56 minus 15, then multiply that by 2. I want to do this first because I do all my multiplication or division first as it occurs from left to right. Now, this is 30. 56 minus 30 is 26. And that is so easy when you use your rules. All right, let me do another one of these. And as I told you earlier, this is going to be a practice test just to keep them back on track for our test next week. All right, let's do one maybe a little bit more involved. Let's do number 6. All right, I'm going to put in 56 wherever I see n. Okay, here's my problem. What do I do first? Well, my rules say any parentheses, you need to clear those out first. Exponents, which we won't have in these problems. Any multiplication or division as it occurs from left to right. Any addition or subtraction as it occurs from left to right. Well, I see parentheses. So I'm going to do this. 6. I'm going to write down everything that I haven't done. I haven't done that. I haven't done that. Sorry, I haven't done that. So, it's getting smaller and smaller. Now what do I do next? Well, I do any multiplication or division as it occurs. What do I do next? Any adding or subtracting as it occurs. And I'm done. And you can see that's their guide. All right, I want to go through a couple here with you. The next section is, and we've done plenty of these, writing a word phrase as an algebraic expression. We had a test last week, a couple of sets of problems, and the students did absolutely great on these. So getting used to these words and what they mean and in what context it will be used in a math problem. Now what this is doing is getting the students ready to work with word problems where they have to write their own equations. In other words, I may have a problem like take away 29 from a number u, which would equal 14. So in other words, they would have to know what this means first. Take away 29 from a number u would be u minus 29. I'm taking 29 from u, and if I said, well, that's 14. So getting used to writing algebraic expressions is going to get them used to solving equations and solving word problems. So there is a method to this madness. There's a reason they're learning how to do this. All right, then we'll talk about these problems in just a few minutes. All right, let's go back and just start all over. All right, the students look for their key words. I'm numbering all these as far as I can get down. All right, there. I've got my keywords underlined. Take away 29 from u. I know it's going to be either u minus 29 or 29 minus u. And I've told you this before in my last video. And I've also told the students, if you're confused, write it down both ways and then place a number in the expression. I'm just going to use 4. And then put that number back in your original expression. Take away 29 from 4. Well, which one of these says to take away 29 from 4? Well, if I take 29 away from 4, I'm not going to have anything left. I'm going to get a negative answer. So it's got to be the top number. I'm taking 29 from 4. And you can see how these key words must be noted when you're doing one of these problems. You really have to think about it. After you get an answer, go back and say, does this really make sense? All right, I'm going to get these answers done real quick, and then I'll point out a couple of things. Decreased, you're decreasing 26 by y. So whatever y is, you're going to take it away from 26. Now, these are tricky. You're dividing into. So it's either going to be 26 divided by j, or j divided by 26, or 22, excuse me. Okay, now which one is it? Well, I'm dividing 22 into j. Well, I'm going to tell the kids one thing they can do, if they want to, they can write it using their traditional division sign and put it like this. Which one shows that 22 is being divided into j? Well, this one does. Let me highlight that a little differently. This one says that 22 is being divided into j. So how do you write that? Well, 22 divided into j is the same thing as j being divided by 22, which would be this one. Oop, wrong line. Tell the students when I'm so close to the board I can't really see what I'm doing. I've got my glasses on and I just can't get a good perspective. All right, does that say 22 is divided into j? Yes, it does, because j is being divided by 22. All right, I'll do a couple more of these, and then I want to get on to the new study guide for this week. 48 less a number n. Take 48 less some value n. If I said, well, n is 12, well, does this make sense? 48 less 12. Yes, it does, because if I have 48 less $12 I owe someone, I've got $36, so it makes sense. All right, I'm going to do one more of these. Let me scroll down here. Let's see. I tell the student, this is one thing for the students and for you as the parents. It just says the quotient of two numbers. Quotient is a division, but whichever one is listed first in your expression comes first in your math phrase. All right, so that would be the quotient of 12 and a number w is 12 divided by w. You say, why does that matter? Well, if I said the difference of n and 14, these are totally different situations here. So in algebra, the students need to get used to, if it just says difference or quotient, whichever one is listed first in the word phrase, write that one first in their math expression. All right, let me do 11. That's a pretty good one. 25 less than a number d. Well, it's going to be either this or this, one or the other. Which one is it? Well, let's put a number in there. All right, 25 less than d. Let's just use 20. I tell the students it doesn't matter what the number is, as long as it just helps you understand. Which one says 25 less than 20? Well, 25 less than 20 would be a negative number. So this is your correct math expression. Okay? Now then they've got some with two steps, which the students have done very well on these. I'll just do one of those. I'll do this one here. It says the product of a number k and 16 less 4. Alright. So let me write that. First of all, product means the answer to a multiplication problem. I tell the students to make sure they write the number first. That means the product of a number k and 16. You don't write k16 because that does not make any sense. I don't have k16s, I have 16 k's. So I don't have 2 dozen eggs. I have 2 dozen eggs, I don't have dozen 2 eggs. So the number comes first. So I've got 16k, the product of a number k and 16 less 4. Minus 4. Okay? Now, the next one's a little tricky, but once again, this is a practice test. This is the quotient of 20 and a number, so I'm going to do that. And a number. And then it says to square it. Well, the quotient of 20 and a number squared. Okay, so whatever that answer is, then I multiply it by itself. And we've talked a good bit with the students on that one. All right, I'll do this last one because just to remind you all what exponents do, and also you can help your child at home. All right, if you see a little exponent, I'm going to make it a little bit bigger again. Okay, that's plenty big. All right, let's simplify that very last one. Okay, all right, first of all, I'm going to do what's in parentheses first. I'll worry about my exponents in just a moment. Well, this is 10, so this is what I've got. I'm going to simplify that. I've got 10 plus 30 minus 50. All right, I need to do this now. That's 15. So this I haven't done. Haven't done that. Haven't done that. Haven't done that. So I've got this left. I've got 14 minus 10 squared, I forgot to put my exponent, plus 15. What do I do now? 14 squared, minus 24 minus 14 is 10. 10 squared plus 15. Now my rules say to do my parentheses, and I've done that. What do I do next? Well, I'll do my exponents. Well, what does that mean again? All right. When you see that little 2, the big number is the base, the little number is the exponent. The little number says to write me down 2 times. That 2 says write me down 2 times and multiply me together. Okay? 14 times 14 is 196. So 14 to the second power is 196. Minus 10 to the second power plus 15. What do I do now? I've still got one more exponent. I'll write it over here. What does that mean? The little number, the exponent, says to write me, the big number, down 2 times and multiply me. So 10 to the second power, or 10 squared, is 100. So now I've got 196 minus 100 plus 15. Okay, what do I do now? I use my PEMDAS rules. I've done all my parentheses, all my exponents. Now do any multiplication or division. I don't have any. So now I go back, I'm running out of room. I do any adding or subtracting as it occurs. So this comes first, that's 96. So I cleared out all this, 96. And now the last thing I'm going to do is 96 plus 15, and that should be 111. Okay? And I hope I didn't make a mistake. I rushed that one pretty quick because I want to get on to my new study guide. All right, but that we'll be doing that. All right, now I'm going to show you the new study guide for this week. And I'll talk about it briefly. I want to qualify what I'm going to say first of all. I'm going to show you what the students will need to know eventually, but right now, all they need to do with one-step equations is find the answer. And I'll reiterate that in just a moment. All right. What are one-step equations? An equation is a statement that says that 2 expressions are equal. A one-step equation has only one operation: addition, subtraction, multiplication, or division. In most cases, now this is very important, the students can find the answer using mental math, but they also need to understand how to show that they perform the inverse operation to arrive at the correct answer. Now, as I go through a couple of these, I'll explain that a little bit more, because you're going to see a lot of things here that the students do not need to show in 5th grade, but they need to understand how they arrived at an answer. Next year, they will have to show these things, so this is preparing them for what they'll be facing, but I will go back over and I'll show you all they will need to know for this year. There's 2 types of equations. I've told you this before. Numerical, that just means there's numbers. If I said 1 plus 2 equals 3, that's a numerical equation because there's only numbers. Now, if I said y plus 2 equals 3, that's a variable equation because I've got an unknown here. I don't know what y is right now, but I'm going to find out what it is. So it's my job to do this. It's my job to make this equal. This one's already equal. But it's my job to find a value for y to make that a true statement. And I'll show you how we'll do it. And this will not take too long. So just now, all the students are going to do this week are adding and subtracting equations, because we're going to hold off on multiplication and division until we've done our little multiplication and division unit. But I went ahead and put these here to show you that you use the same rules. There's only two things you need to remember. Excuse me. Only two things you need to remember. Now I'm going to get a blank screen up here, and I'll do a couple of examples. Two things you need to remember. One, is that to find that answer in real life, we generally do the inverse or opposite operation. And the other thing that you need to remember, that is, if you show it that you're doing this on the left side of your equation, you have to show it on the right. Now, I'm going to go back over again what the students are required to do for this year, but right now I do want to show you the steps. All right, first of all, if I'm thinking about, there's a number out there plus 4 to give me 16. Well, what is that number? The quickest way for me to find that answer is just say, hey, you know what? Let me go backwards. I don't need to start counting up. 4 plus 1 is 5. 4 plus 2 is 6. 4 plus 3 is 7 until I get to 16. The easiest way for me to get my answer is to do the inverse operation. Hey, 16 minus 4 is 12. So 12 plus 4 must be 16. All right, now that's what that means by the inverse operation. So let me do a couple more here. What if I've got y minus 12 equals 31? Well, there's some number out there, y, that if I took 12 away from it, I'm going to get 31. Well, I can start guessing. I can say, well, let's see. Is 40 minus 12 31? No. Is 38 minus 12 31? No. The easiest way to find that answer is to say, look, you know, if I add 12 back to 31, won't I get what I started with? And I do. So 43 minus 12 is 31. All right, so you can see what we do in real life. We do this every day to find an answer. We work backwards. It's just like you're trying to find your way out of the woods. How do you do that? Well, you trace your steps backwards. So that's basically what I'm doing. Well, the next thing in your study guide says, whatever they do to one side, do it to the other. And there's where the word equation comes in. The word equation, the root word, is equal. All right, so that means whatever you do to the left side, you do equal things to the right. So let me show you the formal steps, and I'll show them in two different manners here. Okay, if I had this problem here, a minus 6 equals 19. There's some number out there, a minus 6 will give me 19. Well, I can look at that and use mental math and say, look, I already know that if I just start guessing, I'll get it. But the easiest way to find this answer is just to add 6 plus 19 and get 25. All right, well, let me see if that's right. Is 25 minus 6 19? Well, yes, it is. So I got my answer very quickly. That's all the students will need to do this year, is to be able to use mental math to find the equation. Unfortunately, some of the problems they will do later on this year, maybe two-step equations, require a little more work, so they need to know the process. All right, but I'm going to show you two ways to write this. First of all, I'm going to do the inverse operation, but I'm going to do it to both sides. Everything on the left and right, if you keep it balanced, just think of it as a scale. Next year they'll have to show other steps, and y'all have gone through your algebra classes in middle school and high school yourself as parents, so you know what your teachers require. So that they need to get used to it. Now I can show it going vertically down the page. I can say, look, if they subtract 6, I'm going to add 6. If they subtract 6, I'm going to add 6. So you can think of it like that. Well, when I do the inverse operations, I think of it like I'm stepping forward and stepping back. If I step back 6 steps, and then I step forward 6 steps, I'm right where I started. So they cancel each other out. So A is left here. 19 plus 6 is the last thing the students do is they need to go back and check it. Put their answer back where A is. If A is 25, A minus 6 must be 19, and it is. So you check it. Well, that's one way to write it. I'll show you another way to write it. And this is the way I've written it on the study guide. You can just write it going horizontally across the page. So if they subtract 6, I'm going to add 6. I'll tell the students this. Think of it like this is your enemy. Whatever they do, you can do the opposite just to get back at them. So if they subtract 6, I'm going to add 6. And I'm just going to write it this way. And if they do it here, I'm going to do it here. When I add and subtract the same number, you get 0. That's gone. A is the only thing left, and there's your answer again. So I go back and put my answer back in, and I'm done. All right, let me do a couple more, and you can see I've given examples on the study guide, and then I'm going to show you one area that causes problems for the students, and then we'll move on to function tables. All right, let's do D plus 37 equals 94, okay? Now, all the students need to do, remember, is find an answer. Well, this is a little harder. So the students need to realize, what is the best way for me to find my answer? If I know there's a number D that I can add to 37 to get 94, how am I going to do it? Well, I can guess and check. I can say 1 plus 37. Oops, not big enough. I can try 89 plus, oh, that's supposed to be 37, by the way. Let me change that. Mislead you. Well, that's too little. 89 plus 37, whoops, that's too big. All right, so what do? Well, I can guess and check all day, and it may take me a while to get it, but the easiest way to do it, remember, is to work backwards. If there's some number added to 37 to give me 94, why don't I subtract 37 from 94 and I'll arrive at my answer? Now, the students, the only thing they need to show, and I can't emphasize this enough, in 5th grade, the only thing they have to show or justify is the answer. So they can just simply go off on their scratch paper, do their work, and D is 57. Now, then they need to go back and check it, of course, to see if it's right. Is 57 plus 37 94? Yes, it is. Then I know I'm right. This is what they'll need to do in the future, however. So I will show it to them, but then none of this that I'm showing you right now has to be on paper. I would prefer it would be, but they're not going to be graded on this. They're going to be graded on their ability to find the answer using the inverse operation, not necessarily showing their steps. When I do this, these cancel out, that's 0. D is, and then you subtract, you get the same thing. Okay? Now, you can also do it vertically down the page like I did originally. Now, let me do one more, and then I'm going to show you a little issue here that's going to crop up. All right, let's say I've got F plus 31 equals 68. Okay, there's some number out there, F, plus 31 to give me 68. I can guess and check again. I can guess and say 31 plus 50. Whoops, too big. 31 plus 5. Whoops, too small. 31 plus 84. Whoops, too big. Now, I could do that all day, but the easiest way is to do the inverse. Excuse me. I can take 31 from 68, and I can get my answer. Well, there it is already. Now, I'm going to put it way down here because I'm still going to show you your steps. If it's an equation, your rules say to do two things. Do the inverse operation to find the answer and to do it to both sides. So I'll show you that again. Just to let you know, this is the proper procedure. They do not have, that's not part of their standards in 5th grade. They just need to find the answer. All right, but I will show you. All right, if they add 31, I'm going to get it back. I'm going to do the opposite. I'm going to be stubborn. I'm going to do the opposite. All right, so there's my inverse operation, my inverse operation. When I do this, that cancels out to 0. F is left. I get my answer, and there it is. Then go back, check it, and I'm right. Okay? Now, I'm not going to worry about multiplication and division today. I'll do that later. This is enough for the students. But I want to show you one issue that's going to come up this week as far as equations. What if I do this? What if I have 37 minus F equals 9? Well, this is a little different because all of a sudden I don't have my variable first. And that throws the students for some reason. They just get all torn up and say, well, I don't know what I'm doing. But this is all it's saying. I'm going to show you a couple of ways to show this mathematically, but then I'll just show you the easiest way for the students to do these. And I tell them this every year, but some of them still have trouble. All right. This says there's some number. If I take it away from 36, I'll get 9. Well, let's think about that. Let's just do an easy problem. One strategy to use if you're stumped is to do an easy problem. An easier problem, let me say that. 10 minus what is 8? Well, 10 minus 2 is 8. The students say, you know what? I can do that in my head, but how can I do this one quickly to find out what f is? Well, in this case, if I find the difference between those numbers, I'm going to get 2. Okay? So I tell the students this year, all I want you to do is be able to find the answer using mental math. So if the letter is being subtracted, go ahead and find the difference between these two numbers, 36 minus 9. Okay, and f is 27. Just make sure you go back and check it to make sure it checks that it is correct. 36 minus 27, is that 9? Yes, it is. Well, let me show you what they'll be seeing later, next year especially, so they may as well understand the process. Now, you can do this so many different ways, and they're going to see it a couple of different ways next year. Let me just get rid of the whole thing so you can see it better. Okay. Now, as I told you earlier, the students don't have to show all this, but I'll be showing them this, and they'll get confused, and I'm sorry for that, but I want them to understand what happens. You can do this. If you can turn this into another statement and have the letter first. Okay, I'm going to do that. You can do that a lot of different ways, but all I'm going to do here is I'm going to tell the students, we'll do whatever, you do the opposite of whatever's happening there. Well, they're subtracting f, so I'm going to add f. And so that's crazy. This is just one way to do it. Okay? If I add f to both sides, they disappear. So 36 is over here. What's over here? Well, 9 plus f. You say, well, that didn't help me a bit. I still don't know what f is. But what that did was it made the student see that I've turned it right back into a problem like we've been doing. Now, they say, well, look, the f's over on this side. Well, move it over here. You can say, well, look, there's nothing wrong. This is the same thing. That if I've got 9 plus f, over here it's the same thing as having it over here. So now it's a little more familiar. They say, well, it still doesn't look like the ones we've been doing. It's still different. What about it is different? Well, they say, well, I like my letter to be in front. So I'm going to do that. Well, now it's just like what I did a minute ago. Now I can say, ooh, that's easy now, because I know if I do the inverse, f is left here because that cancels out, and there's my 27. They say, look, isn't that crazy to write all that down for that little problem? I say, in a way it is, but this is getting them ready to work harder problems. So, when your child asks you that, just say you had to do the same thing when you were in middle school and high school, because you did. You had to show the inverse operation, you had to show every step, and as your math classes got more and more advanced, it got more and more involved. So we start out easy to help them to harder. I'll emphasize this again. If they can find this answer just by saying, hey, all I got to do is say 36 minus 9, that is just fine this year, no problem at all. Now, we'll be having plenty more problems there, but that's just an introduction. Now, I do want to talk about function tables briefly. Now, when you and I were in school, we didn't do a whole lot of function tables. I didn't. I'm probably a lot older than most of y'all. But we didn't do a whole lot of function tables. Let me get, there we go. But this goes right along with what we're doing with expressions and equations. All right, now let me show you what a function table is. A function table shows the relationship between two numbers, all right? And I've given you several examples. Now, what happens here is the value of one is totally dependent on the value of the other and what happens to that number. You've seen it in your child's younger grades as maybe an input-output table. Input-output table, and it might have been a little bit of a function machine. It looks like a little machine, a bread making machine or something, where you pour something in and what do you get out? Well, it's the same thing here. You take a value, this would be your input. I'll just concentrate on this one here. This is your output. When you do something to one, something else is going to come out because you've changed it. All right, so let's just look at the very first one. Let me make this a little bigger again. I know you probably got your study guide with you, but it makes it easier for you to see what I'm writing here. All right, we're almost done. I'm not going to spend a lot of time on these. I don't want to talk about rules briefly, though. Finding a rule when you don't know it. All right, x plus 13. All this is saying that is the value of y is a function of the value of x and what happens to it. In other words, you're going to do something to x, and that's going to tell you what y is. So let's assume, all right, I'm going to do something here. I'm going to get rid of these. They're gone. Okay, what if I don't know y? Well, I do know x, and I do know that if I do something to x, I'm going to get y. And in this particular problem, if I add 13 to whatever x is, I'm going to find out what y is. So all you do is you substitute these values back in your original statement, y equals x plus 13. Well, if x is 1, 1 plus 13 is 14. If if x is 2, 2 plus 13 is 15. If it's 3, 16. If it's 4, 17. And I found my missing values. All right, so all you've done here is taken what they've given you and said, I think I can do this. I can just substitute my values, whatever's given to me, and go from there. Now, I'm going to get rid of this and I'm going to show you. There it is back. All right, I'm going to change this one. I'm going to get rid of some of my x's and some of my y's. Now, let's just... That's good enough. That's plenty. All right, now, this one says that if x is 10, what would y be? Well, I'm going to do something to x. I'm going to take 7 away from it. So in this case, x is 10, x minus 10 will give me y. So, is 10 minus 7 3? Yes, it is. All right, let's do the next one. 9 minus 7 is 6. Now, this one, a little different. All of a sudden, I know my answer. I know that y is 1. Well, what is x? In all these problems here, I started out with x. And all of a sudden, I don't know x, but I know the answer. So all I do is put this back into my original statement and ask myself, what minus 7 will give me 1? And this is where the use of one-step equations will pay off, because they're going to say, well, you know what? If I add 7 and 1 together, I'll get my original answer. And you can see you can work backwards. All right, I'm going to do one more of these. Okay? All right, I'm going to erase some of my values. I'll just skip every other one. I probably didn't mean to do that one. Let's see here. All right, let's just do that. That's good enough. Doesn't matter. All right, this one says that there's some value for x that will give me 8 for y. So if y is 8, 1/2 of what number will give me 8? Well, if I look at it like this, if I doubled x, excuse me, if I doubled y, I'll get 16. It's 1/2 of 16, 8? Yes, it is. Now, in this case, I know x. What is 1/2 of x? Well, it's 7. Is 7 1/2 of 14? Yes, it is. X is 12. What is 1/2 of 12? Well, it's 6. Is 6 1/2 of 12? Yes, it is. And you can see how you do. All you're doing here is using the statement given to you and going from there. Now, there's going to be times when you don't know your rule. And I'm going to do that in just a moment. I think I've got a document pulled up where I can show you. Sometimes there's going to be some missing blanks here. In other words, you may have the same situation I just showed you. Whoop, wrong color. There we go. You may have some of these missing, and you don't even know what your rule is because the rule was not given to you. Well, I'll show you what to do there as well. Okay, let's look down here at the bottom. I just want to show you a couple of things real quick. I tell you that sometimes the students will need to identify the rule, and toward the end of the week in your study guide, in your newsletter, I'll tell you we're going to have some practice problems on that toward Friday. All right, I do want to emphasize this. Please, and I just saw a mistake. Amazing how many mistakes you can make. All right, make sure your child is still studying their time stacks. There's nothing more frustrating than for a student to have to do a problem like this and try to teach them the methods, the algorithms that we're going to use to help solve. I'm going to show them how to do lattice multiplication and so on, and several other ways. But there's nothing more frustrating for a child to get to here and say 4 times 8, and they just stare there, and then they look at this whole problem, and it's overwhelming for them. Now, I've said this before in my newsletters and in these videos. We just don't have time in school to do time stacks. I wish we did, but we don't. In 5th grade, as a matter of fact, our new math book doesn't even have multiplication in it. It's assumed that 5th graders know everything they need to know about multiplication. Now, we know that's not true, but see, it's not even in your 5th grade standards. It's assumed that they know that. We're supposed to go immediately to division and not even worry about multiplication. But we can't do that in reality. So your child needs to make sure they need to study their time stacks. I'm going to show them some other ways to multiply and some tricks. I'm going to show them, and I'll probably attach a couple of videos on finger multiplication where the kids can do 6 through 10s, 6 times whatever, 6 through 10s with their fingers. But the bottom line is they just need to memorize them. I'm going to be very upfront with you about that. There's no quick way other than the best way, in my opinion, is to memorize. All right, let me go do a couple of function tables, and I hope I've got this up. Let me see. I think this, yeah. All right, I'm going to come down here. This is one thing we'll be doing toward the end of the week. You can see where I'll do one of these, and I want to do one with a rule. All right. Let's do this one here. We'll just do part of it. It says that if I want to find out what y is, I'm going to take half of x. And remember this here, this is why we spend so much time on expressions. They need to be able to recognize what that means. That says that x is being divided by 2. You say, well, that's a fraction, but the students have learned repeatedly that this means division. Okay, so if I divide 20 by 2, I'll get 10. I've got my first answer. Now, in this particular one, though, I know y. Y is 6. Well, I've got to work backwards again. Now I've got to say, well, look, if y is 6, 6 equal what divided by 2? Well, they have to think, hey, you know what? If I divide 12 by 2, I'll get 6, because 2 times 6 is 12. All right, so there's one with a rule. Now, toward the bottom, though, there's some that they have to find the rule. Identify the rule. And I just want to show you how these will be written. And the students will get versed on this pretty extensively. So if they pay attention, this is not hard. All I'm doing here is looking at the relationship between these two numbers and seeing if I can establish some kind of pattern. Well, you can look at that one and say, yeah, I see a pattern. Y is 5 less than x. So how would you write that? Well, to find y, what am I going to do to x? I'm going to do something to it. Remember, the value of y is a function of what happens to x. In other words, what do I do to x to get y? Well, if I take the value for x, 30, and I take 5 away from it, well, I always get y. And here's the kicker here. It's always got to work. You can't have a rule that works here, but doesn't work there. Works here, doesn't work there. So when you come up with a rule, it's got to work in every case. And this does. Whatever x is, minus 5 will give me the answer. Let me do one more, and we're almost done here. All right, when I'm getting these, I will make sure you understand that, if you have questions or comments, please use email, call me, or whatever on any of this. All right, let me do this one here. How do I go from x to y? Well, I noticed something. There should be a pattern that's developing in all these. Well, there is. I noticed that y is half of x. So how do I write that? Well, I can't just do this. I can't say, well, I can't write y equals 2 into x. That's not appropriate. But I can do it a couple other ways. I can say this, that y is 1/2 of x. That's appropriate. Or I could say that y is x divided by 2. So either one of those would be fine. Now, down at the very bottom, we're going to do some two-step rules. And students do well on these because they are challenging and they seem to like them. So I'll just look at this one. How can you go from 0 to 1, from 1 to 4, from 2 to 7, and 3 to 10? Well, there's two steps involved here. Usually if there's a crazy looking pattern, something that you just can't identify like these up here, there's two steps going on. Well, first of all, it's increasing. It's getting bigger every time. So that leads me to believe, how do numbers get bigger? Well, normally you can add or multiply. Well, let me think here for a moment. How in the world can I go to multiply 0 by something and then get 1, multiply 1 by something and get 4? Well, I just experiment. I'm going to guess and check a little bit. All right. If I multiplied 0 by 2, okay, and add 1 to it, 2 times 0 is 0, plus 1 is 1. That worked. Okay, so maybe it's y equals 2 times x plus 1. Well, let's try here. What's 2 times 1? Well, 2 times 1 is 2. 2 plus 1 is 3, so it didn't work. So let me try another rule. And I'm making this short. To just show you the process. The procedures I show the students, they'll get the hang of it because I tell them to look at patterns. Okay, well, let's try 3 times x plus 1. 3 times 0 plus 1 is 1. Well, let's try this one. Let's try 3 times 1 plus 1. 3 times 1 is 3. All right, that's a possibility. Let's see if it works here. What's 3 times 2 plus 1? Well, that's 6. Is 6 plus 1 is 7? So I found my rule. My rule is y equals, I'm going to double x and add 1 to it. So that's the process we'll be using. It'll be a little bit more detailed than I'll just show you. But I want you, if your child comes home and says we're doing identifying rules of function tables, that's what they're meaning. All right. I hope this helped you. I hope you have a good weekend. Let me know if there's any problems with any of these explanations. I'll be glad to help you individually. All right. Thank you very much.